So yesterday we started a new course called Joining Data with Pandas in Python, where we learned how to perform an inner join in Python. So if you are familiar with data modeling, so inner join is quite popular in SQL too, and in Excel and Power BI. Wonderful that it's good to know that you can actually perform same inner join and other join types in Python also. So that's what we started learning yesterday in the new course called Joining Data with Pandas in Python. So I'm just going to continue from where we stopped yesterday. So yesterday we started joining data together, one or two or more tables together in Python. If I just show you what that looks like really quick here. You can see, so we merge actually we connected to a data set, taxi owner data set, and another data set called taxi vehicles. And we're able to merge the two data sets together using this code here, this simple line of code here. Merge, okay, let me zoom that in a little bit. We're able to merge the two data sets together, this taxi owner data set with taxi vehicle data set into a single or tabular table in Python. So all of this was done on day 31 live stream. So the goal and objective of this live stream is to learn and master Python over the next 100 days. So we started learning all the way from day one. So if you want to start from scratch, I encourage you to go to the live stream tab on the channel. Just go to YouTube and search Excel Island on YouTube. You're going to go to the live stream tab, then you have access to all what we've been learning over the past 31 days so far. So I'll just zoom out a little bit and zoom in. Okay, I think it's better. So you can see. So this was what we started, journey data with pandas. You can see the last checkpoint was yesterday. So I'm just going to continue from day to day and spend at least an hour daily trying to master Python over the next 100 days. Then we also did some simple analysis yesterday. You can catch all of that on the 31 live stream. So without further ado, we're just going to continue from where we stopped yesterday. Okay, I'm just getting my headset on. So while that is coming up, if you want to have access to all the data sets that I'll be using throughout this learning journey, it is already linked under the YouTube description. Just go to the YouTube description. There's a link under it which contain the Python files, the CSV files, the Py files, the Excel files that we'll be using that we're going to be getting connected to in Jupyter Notebook. And so this Jupyter Notebook, this is an environment you use to work with Python. So if you want to learn how to install this, just have access to the Anaconda Navigator, so you can always uh, have access to Python environments and other IDE also, or any environment that you want to use to work as a programmer or a coder or a data analyst or a data scientist. I just continue from there. It says review what you learned to go faster today. Have a recap of your previous learning activity. So let's see. Let's just see what it looks like. Okay. Sometimes it takes time to load. I just have to wait for it. So I think in today's lesson, we're looking at one-to-many relationship. Okay, your recent learnings. When you left 1 day ago, you work on data merging basics, chapter 1 of the course, joining data with pandas. Here is what you covered in your last lesson. We use the merge method. You learned how to use pandas merge method to join two data frames, for example, to merge two data frames, data frame 1 and data frame 2, on a common column name, common column. You would use data frame 1 dot merge, the data frame 2, comma, then the unclone on the common column you want to merge. And you know, inner join mechanics, an inner join returns data frame containing only the rows that have matching values in both tables. So if you are familiar with inner join, left join, right join in SQL, in Power BI, in Excel, there's almost, it's not even they are almost, they are the same knowledge over and over again. So let's just continue from here. So welcome to one-to-many relationships. So let's see what we will try to cover today. We can try to cover the remaining lessons in chapter 1. We have one-to-many classification. We have merging multiple data frames. So let's see how long we can cover within the next 1 hour. We spend 5 minutes on introduction. So let's get to it. Let me just change my. Okay, I think we are good to go.
Welcome back. In the last lesson, we learned how to merge two data frames together with the merge method. In this lesson, we'll discuss different types of relationships between tables. In particular, we will discuss the one-to-many relationship. But first, let's quickly consider what a one-to-one relationship is. In a one-to-one relationship, every row in the left table is related to one and only one row in the right table. We looked at a one-to-one relationship earlier. Recall the relationship between the wards table and the census table. Every row in the wards table is related to only one row in the census table, so there is only one row for Ward 3 in each table. Practically speaking, it only makes sense that there is only one row of population information for each ward. It wouldn't make sense if the census table contained multiple population values in 2000 for the third ward. So, what is a one to many relationship? Well, in a one to many relationship, every row in the left table is related to one or more rows in the right table. To provide an example of a one to many relationship, let's think back to our wards table. Within each ward, there are many businesses. We will merge the wards table with the table of licensed businesses in each ward. The business license data is stored in another table called licenses. It holds info such as the business address and ward the business is located within. The two data frames are related to each other by their wards column. When we merge the two tables together with the merge method, setting an on attribute to the column ward, the resulting table has both local ward data and business license data. Notice that Ward 1 and its alderman Joe is repeated in the resulting table because the licenses table has many businesses in the first ward. Pandas takes care of this one-to-many relationship for us and doesn't require anything special on our end. We can use the same syntax as we did with the one-to-one relationships. By printing the shape, we can see that our original wards table has 50 rows. After merging the wards table with the licenses table, the resulting table has 10,000 rows. When you merge tables that have a one-to-many relationship, the number of rows returns will likely be different than the number in the left table. Now, let's make the one-to-many relationship idea more concrete by practicing.
Okay, so let's practice one-to-many relationship in action. So one-to-many classification. So understanding the difference between a one-to-one or one-to-many relationship is a useful skill. In this exercise, consider a set of tables from an e-commerce website. The hypothetical table are the following: a customer table with information about each customer, a customer tax info table with customers' unique tax IDs, another table with information about each order, okay, a product table with details about each unique product sold, an inventory table with information on how much total inventory is available to sell for each product. So select the relationship type that is most appropriate for the relationship between different tables, one-to-one or one-to-many. The relationship between the orders, product and orders, product and orders, definitely one-to-many, because customers are going to purchase, a customer can have multiple orders, so multiple products, something like that. Relationship between product and inventory. So product is contains unique record of each product sold. Then inventory with information on how much total inventory is available to sell for each product. How much total inventory? I'll go for one-to-many here also. Okay, the relationship between customers and orders. Customers and orders. Definitely one-to-many. Relationship between customer and tax info. Let's go for one-to-one. Ooh, so I missed this products and inventory. There could be multiple products. Hmm. Hmm. I'm thinking what is the best relationship that will be between product and inventory. If it is one-to-one, product inventory. So product is unique. But inventory says information on how much total inventory is available to sell for each product. So each product can have multiple occurrence in the inventory, right? But let's see. Great job classifying the relationship to the right categories. Knowing if a relationship should be one-to-one or one-to-many will allow you to troubleshoot a merge that appears incorrect. I still don't agree with this product and inventory. I know customers and customer tax info. A customer cannot have multiple tax info, so it's definitely one-to-one rather. But for products, multiple products can be available in the inventory, but it's the total product. Okay, that's true. So definitely one-to-one. Okay, let's move ahead. So one to many merge. A business. Okay, let me zoom that a little bit in. So it says a business may have one or multiple owners. That's true. A business may have one or multiple owners. That's true. There could be shareholders, investors in a business. That's true. So in this exercise, you will continue to gain experience with one-to-many merges by merging a table of business owners called biz owners to the license table. Do I have access to that business owners record? And you can have access to business owners. You can say we have business owners data sets here. Then we have a license. Let's see. A license record here. That's good. Recall from the video lesson with one-to-many relationship, a row in the left table may be repeated if it is related to multiple rows in the right table. In this lesson, we will explore this further by finding out what is the most common business owner title, i.e., secretary, CEO, or vice president. Okay, let's see. So the license and business data frame are loaded for you. So the data frame is actually loaded for me in this environment here. All I have to do is to connect to the data sets in my own Jupyter notebook here. So to make that easy, I'll just go down a little bit. Let's just run this whole code one more time. So you can see, so this is just my libraries. I'm connecting to the tax owner data sets in this instance here. Let's see if I get rid of these prints. So I'm going to have it in a tabular form like this, which is much more easier. Okay. So connecting to another data set here. Then in this instance here, we merge the two tables together. This table here, we merge it to this table here based on this. Which column is that? VID column. Based on this VID column, that was how the merge was performed. So that's by the way though. So let's continue from here. So I want to connect to another data set for this second join. I'll just copy this line of code here. So I want to connect to the license data set and biz owners. So you can see the license data set here. Our business now, we have the license data set here, LINCNSES. I just say load license. Did I get the spelling correctly? LICN, that's correct. So I'm not going to change, it is spelled licenses. Okay. So I just change this my .p4 here to licenses. If I call this license data, so let's see it in action. So no error was returned. If I call on the data set now, you can see we have the results here. We have the accounts, words, aid, business, and address and zip code. Let us do dot edge and only return the top five, the first five rows. Because we have over 10,000 rows of data here. Yeah, just 10,000 rows of data and six column. So we actually know what we are looking at. So let us just return few number of rows. The next one is to load the business owners. So business owners data set, which is the data set here. Business underscore owners. Let's take it second look at that. Owners, yeah, that's correct. I just change this .p file to business owners. So I just change the name of my .p file, the file I want to connect to. Let me name my data frame as business owners data. So if I run the code, I shouldn't get any error. So this line of code is just connecting to a, or it is connecting to a p file, .pico file. So that is what we are doing. I'm not actually connecting to a CSV file, probably a Microsoft file or whatever. This is a Pico file. That's why we're actually using the Pico library. That was the reason we imported this Pico library. So this pandas, we are using this pandas to read and manipulate these data sets. That is what pandas is used for. If I run the code now, of what I can see, this is the business owners, the accounts, the first name and last name, the title of the owner. So let's see dot add also. Let's use dot add to actually return the first five rows of data. So I want to merge these two data together based on this word ID rather. I see there's a word ID here. Come on. What's the common column here? Definitely. Uh, let's go ahead and see. Let's follow the instruction first. So start with the license table on the left, merge it to the biz owners table on the column account. Oh, okay. The common column here is the account. You can say account here, the account here. Voila. So that is the common column between the two tables. So let's see. So license and owners. So this is going to be, so I'm just going to copy this line of code here to make the merging easier. So license owners is equal to, start with license on the left. So license on the left. Then biz owners on the right. That is what they actually named their own data frame here. And join on the accounts column. So let's copy this line of code here and try it in Jupyter Notebook first. But I'm going to change this to license data. This is going to be changed to license data. Why this is going to be business owners data. If I should run this code, I shouldn't get any error. You can see no error. So if I call on this license owners data, let me just name it license owners data there. If I run the code now, so we should have more columns. You can see we have few number of columns there. 1, 2, 3, 4, 5, 6. Plus this 1, 2, 3. So 6 plus 3, that should be 9 columns in total. You can see now we have 9 columns. Now you can see 9 columns. We've merged two tables together on a common column. I could just do dots add to return the first 5 rows of data. You can see now. So the two tables was joined on the accounts column, and this was showing over 10,000 rows of data. You can see now. Let's try the same thing here. It now says group license owners by title and count the number of accounts for each title. Save the result as counted data frame. So I want to group the license owners by their title. I want to group this whole data set by the title. You can see we have some partner, some record, some title are repeating here based on, because a business can have multiple or partners, member, presidents. A business can have two or more presidents. A business can have two or more partners. So I want to summarize the data set. I'm just going to use this line of code here. We've done something similar like this. I use this line of this value dot count. Let's see. We want to group by first. So group the result by title, then count the number of accounts. So I want to group by title. Let's copy this title column by title. They want to count, aggregate, then account, counts. Let's see. Let's see it in action here. So this, when aggregating, this is quite different. We are just actually counting straight up. Taxi owners, fill, then count. We only counted just one column here. But this time we want to group and count. Okay, so this is going to be license owners data. So go to the license owners data frame, group by the title, dot counts, count the number of accounts based on this title. So let's see. So if you run this counted data frame now, let's see. Which you can see. So we have uh assistant secretary over, there are a lot of titles, are over 100 assistant secretary, beneficiary, CEO, director, and so on. So you can actually sort it from highest to lowest just to see the most common title in the data frame or data sets. So let's see now. Sort the counted data frame in ascending order. We just sort in ascending order. Let's copy this line of code. So if you sort this in so count difference this data frame. Let me just return top 5 rather, so I can have enough space to work with. We just have the first 5. It's only return the first 5 rows, but let's sort it by values. Sort the counted data frame in descending order. So sorted data frame, this data frame here, the sort values. I'm going to say ascending equals to false. So it's going to sort from highest to lowest. Oh, come on. Oh, sort values. Oh, okay. I need to mention by my sorted. Okay, I need to mention what I want to sort by. Let's see. Sort values. Okay. I need to mention by. If I want to sort the values, okay, hold on, hold on. Let's sort by accounts. We're sorting by accounts. Then comma. Voila. So I need to sort by this account, then descending. If I call on this sorted accounts, sorted data frame now, I show my result. You can see. So the highest here is president, followed by secretary, then sole proprietor, others. You can see now. If I return the first 5, If you return the first 5 here, you can see the highest title here is the president. So let's see. Let's copy this line of code here also. And make use of it in this instance here. Sort by account ascending. Use .add method to print the first few rows. Okay. I'm just going to do the same thing here. Dot first few rows. Let's run the code and see. You can see what we have. We have similar results here. You can see 6259. The president is the highest title in the data frame. Then followed by secretary, then sole proprietor. Similar thing we have here. So that's interesting. Let's see. Sorted difference. Okay. What is it trying to tell me here? What is the error here? Let's see. Oh, okay. I didn't print it out. Okay. I'm missing two more brackets there. On code. Voila. So the first few 1, 2, 3, 4. Even if I use .add here, if I'm using .add here, I don't need to mention, I just need to cover it up. Then I'm going to return the first 5 as usual. The first 4, 1, 2, 3, 4, 5. The first 5 as usual. I say you want to return a certain amount of rows, then you mention the number of rows you want returned there. So wonderful. After merging the tables together, you counted the number of repeated rows with the combination of goodbye and dot aggregate statement. You see that the president followed by secretary are the most common business owners titles. That's correct. Okay, ignore this. I've just been learning some other stuff on the platform for the last 100 days. So let's try to solve this last challenge. Merging multiple data frames, total riders in a monthly table. So we want to merge probably 2 or 3 tables together. Definitely more than 2. We want to calculate total riders in a month. 3 table merge, one to many relationship with multiple tables. Okay, let's see. Let's see this challenge.
Welcome back. In our last lesson, we learned how to merge two tables with a one-to-many relationship using the merge method. Merging data like this is a necessary skill to bring together data from different sources to answer some complex questions. Sometimes we need to merge together more than just two tables to complete our analysis. In the previous lesson, we used two tables from the city of Chicago. One table contained business licenses issued by the city. The other table listed info about the local neighborhoods called wards, including the local government official's office. Now, we also have a table of businesses that have received small business grant money from Chicago. The grants are funded by taxpayer money. Therefore, it will be helpful to analyze how much grant money each business received and in what ward that business is located. We then could determine if one ward's businesses receive a disproportionately large amount of grant money. To pull all of this information together, let's first connect our grants table to our licenses table. The two tables are related by their company name and location. Let's pause here for a moment. If we merge the two tables using only the zip column, then a 60616 zip of Reggie's Bar from the licenses table will be matched to multiple businesses in the grants table with the same zip. Our code sample prints the first few rows and some columns of the merged table. The output of the merge duplicates Reggie's Bar for each matching zip in the grants table, which is not what we want. If instead we merge on address only, there's a small risk that the address would repeat in different parts of the city. Therefore, the best option is to merge the tables using the combination of both address and zip code. We merge the two data frames as shown before, except in this case, we pass a list of the column names we want to merge on to the on argument. This allows us to use multiple columns in the merge. As before, the matching rows between the two data frames are returned with the columns from the grants table listed first. However, when we merge on two columns, in this case the address and zip code, we are requiring that both the address and zip codes of a row in the left table match the address and zip code of a row in the right table in order for them to be linked to each other in the merge. We can now extend this example to a third table. First, we merge the grants table with the wards table on the ward column again, adding suffixes to the repeating column names. Note that we're using Python's \line continuation method to add the second merge on the next line. Python will read this as just one line of code. Without this, Python will throw a syntax error since it will parse it as two separate lines of code. So don't forget your \. Now our output table has information about grants, businesses, and wards. We can now complete our analysis. We can now sum the grants by ward and plot the results. Some wards have received more grants than others. We could continue to merge additional tables as needed. We stopped at 3, but if needed, we could continue to add more. The code here shows the pattern you will follow as you merge more tables. Now, let's practice merging multiple tables.
So you can actually merge 2, 3, 4, 5 or more tables, depending on how many tables you have access to. So let's solve these last 3 challenges, and that means we'll be completing chapter 1 of this lesson. So total riders in a month. Merge the ridership and call tables. Let me check if I have access to those tables. Let me check here. I have a table called crazy. Do I have riders there? Oh, I won't be able to do that in this place here. Let's probably have a table that I can use for this challenge, trying to merge 2 or more tables together. Let's see. So your goal is to find the total number of riders provided to passengers passing through the Wilson station. Station name is Wilson in the record. So when riding Chicago's public transportation system on weekdays, date type is weekday in July month 7. Luckily, Chicago provides this detailed data, but it is in 3 different tables. We will work on merging these tables together to answer the question. So this data is different from the business related data you have seen so far, but all the information you need to answer the questions, to answer the question is provided. The call, ridership, and station data frames have been loaded for you. The relationship between the tables can be seen below. Okay. Call is related to ridership via the year, month, and day column, while ridership is related to station table via the station ID. So there's definitely, this is one to many here. They definitely one to many here because this is the rider, this is the caller ID that booked the ride. This is the ridership information and the rights of the post of the rider. So merge the ridership and call table together, starting with the ridership table. Because the ridership table will be merging to, we'll merge that to the call table. We'll merge it to the call table, comma, on merge the ridership and calls table together, starting with the ridership on the left and save the result as ridership call. So on which column? Ridership to the call table. So we're merging on 3 columns: year, month, and day. Oh, so I'll be mentioning 2 or more columns there. So I also come up with this square brackets. So the first column there is year, comma, nope, comma month, then comma day. Okay, let's run and see. So that's correct. So we're able to merge that two tables together easily. So extend the previous merge to three tables by also merging the stations table. So we're going to add the stations table now, then comma. So the table I want to be merging now is the station table. Merge stations. I'm going to add stations to it. Stations, these stations here, then comma, that should be on which column, which is the station ID. Station underscore ID for this to work. So let's see, let's submit this. So that's correct. Now we need to do something else. To create a variable called filter criteria to select the appropriate rows from the merge table so that you can sum the right column. Create a variable called filter criteria. Okay, use dot log and filter to select for rights only. Okay, we've done that. Okay, this is the filter criteria here. So how do you do that? Filter criteria equals to ridership call stations months equals to, hold up, let's see how to solve this challenge. Create a variable called filter criteria. Select the appropriate rows from the merge table so that you can sum the right column. I want to sum this right column. Okay. Checking out to solve this. So ridership, this is the of the month column equals to for which month? Okay. Month 7. Let's see. Where the data type for the month 7, data type is weekday. Okay. Data type is this. Data type is weekday. And the station is Wilson station. Is Wilson station. Okay, so create a variable called filter criteria. Select the appropriate rows. Okay, from the merge table so that I can sum the right column. Okay, what that is selecting, we are selecting you want to know total number of rides provided to passengers passing through racing station on a weekday for the month of. So that's what we are doing here. So selecting the month column, the 7th month, and the stations, the weekday station for the Wilson station name. Okay, let's see. Let's run the code and see. So we have over 140,000 rows there, 140,000 rides passing through this Wilson station on a weekday for the month of July. Correct. Let's submit that. Oh, voila, we nailed it. So awesome work. So you merged three data frames together, including merging two tables or multiple columns. Once the table were merged, you filtered and select just like any other data frame. Finally, you found out that the Wilson station had 140,000 riders during weekdays in July. So that's how we're able to filter the data based on these rows selected. Okay. The column name, column. You mention a criteria. So let's continue. Okay, since we'll be using the license and zip demo. Let's see if we have access to these data sets. We have the license data sets here and zip demo here because we have access to the data set. So I'm going to perform probably 3 or 4 merges in this next challenge here. So let's see. 3 table merge. Okay, 3 table. We want to merge 3 table this time around. So merge license and zip demo on zip and merge it words on words. License zip words. Okay, let's give it a shot. Okay, license and zip demo. Let's see. Zip underscore demo. So I've not connected to the zip demo data set in this place here, but I'm actually connected to the license data set here. So let me connect to the zip data set here rather. We have the license data set here. We have the business owners data set here. Do you have the word data sets? We're using license, zip demo, and words. Let me see if I've connected to the words data set here. This word here, I haven't. So we have the license here already. We really did license. And then I've connected to the words data set here. Let me just run every kind of code again. Okay, I think we are on this last part. So all I can just what I can do is just to call on the tables, the data frame I want. I think I have the okay, let's see. Let me see here one more just double checking. License. I have the license data set here. License owners data sets. I have it here. What else? Zip demo. I don't have access to the zip demo. So what I'll just do, just go back a little bit up. This license, this zip demo. Let's copy this. Let's add a line of code there. So we want to do zip demo here. Zip underscore demo. Then this should be zip demo. Okay. Underscore here also. Control C. Zip demo data. Then I'm just going to change this to zip demo. Now let's run this line of code and see. No error there. So let's call on zip demo and see what it looks like. Because we have zip demo here. I just do dot edge. So I have my zip demo data already here. So I have these 3 data sets here. We have zip demo here. We have license. We have zip demo. And the last one is word. That word data. I think I've loaded that since yesterday. We used the word data yesterday. Is it word sensors or word data? The word. Okay, let's see. This is the word data here. We've actually made use of it since yesterday. So now I want to merge these three tables together in a new. So I want to merge this license data to the zip data to the word data. So that's what we want to try to do. Three or more tables merged together. Okay, let's see now. License zip word. The first one is the license table on the left. Dot merge to zip demo on zip. Let's see. License and zip. So there's a zip column. You can see zip column, zip column. So on zip, that should be comma on zip, then followed by dot merge. So we imagine that table to the words table, comma on words, and merge the resulting table to the words table on word column on words. Let's see. Save the result of the three made tables to a variable named license zip word. Okay, let's see. Let me copy this and let's try it in Jupyter Notebook here. So in our case here, license zip word, our license data is called license data. Data here. Then our zip demo data is called what here? Zip demo data. Finally, our words data is called words underscore data. Voila. So it worked fine, no error. We just call on this license zip word. License zip word. Let's see how many rows of data we have. Over 19,000 rows of data, you see, and 30 columns. Can you see now? We've merged three columns together. Let's return just few rows of data. So we have more space here. Voila, we have few rows of data. That's the first four. 1, 2, 3, 4, 5. Okay, so what we need to do next is to print the result by Alderman and show median income. So I want to print this license zip data, license zip for data by this. I want to group it by this Alderman column, this column here. This column, I want to group it by this column. I want to group it by this column and count what analysis we want to do there. We want to group it result group the result of the three made tables by the column Alderman and find the mean income. I want to look at the mean income of these auditors. Where is the income column? Income. This income. What is the mean income for this variable income here? So how to do that? Go by that column, mentioned column. Then income, median income. So let's see it in action. So it's going to group it and give us the median of each Alderman of this record here after grouping. So let's see, let us see the results. Well, I can see the mean income. You can see the mean income for each what? For each Alderman. So I'll just get rid of this print here and run it again. So you can see the results much more better. You can see the mean income for each what? For each Alderman. Let us run the code here also. We should have the same results here also. Similar results. Voila, we need it. Nice work. So you successfully merged three tables together with the merged data. With the merged data, you can complete your income analysis. You see that only a few Adama represents businesses in areas where the median income is greater than $62,000, which is the median income for the state of Illinois. I think I pronounced that correctly. For the state of Illinois. So let's continue. So one to many merge with multiple tables. Ooh, one to many merge with multiple tables. Let's just do dot edge here. Dot edge. Just have a few rows of data returns. So it says in this exercise, assume that you are looking to start a business in the city of Chicago. So your perfect idea is to start a company. So your perfect idea is to start a company that uses goats to mow the lawn for that business. However, you have to choose a location in the city to put your goat farm. You need a location with a great deal of space and relatively few businesses and people around to avoid complaint about the smell. You will need to merge three tables to help you choose your location. The land use table has info on percentage of vacant land by city ward. The census table has population by ward, and the license table lists businesses by ward. The land use census and license tables have been loaded for you. Let's check if we have access to this land use, census, and we have licenses here, no doubt. We have access to the license data here. We want to check the businesses, census, and land use. We have land use here. We have census here. We have a land use data here also. So let's connect to the data sets in Jupyter Notebook. Same way we've been connecting to the data sets over and over again. Let's see. Um, I want to see. I can just go above here. Use license owners data. Let me just come here and add connect to another data set here. We've actually connected to a lot of data in this lesson. So we have the land license owners data already. I want to connect to the land use. Let's see. Land use and census. Do you have access to the census data already? I think we do. Census. We have census here already. So I'll just connect to let's connect to it. Let's see census here. Census data has been connected to before. Okay, we've connected to the census data before. Let's just connect to the land use. I have the license data already here. I copied something just a few minutes ago. It should be under here. Nope. This census data here. What I want is the license. Next one should be the license owners data. License. Okay. License. We have the sensor data license. We want to do what's the next data set we need to connect to? That should be the land use data. We want to connect to the land use data. This land use data. Let's see. License, sensors. We need to connect to the land use data here. Let's see. Load zip demo data set. I think we've loaded zip demo data set here. Okay, we have it here. So this is what I want to use. So load license, land use. I want to load the land use data set here. I want to load the land use data sets. Land use data set, which is named actually as land underscore use. Land underscore use. So just copy this land use data sets. Land use. I'm just going to zoom out. Just go to the right there rather. Land use dot p. So we're going to call it land use. So let's run the line of code. No error. We are good to go. Control C land use. Because we have a lot of information here. Let's do dot add. I think the land use data set here. Control C and let's scroll down. So we need to merge these three data sets together. Sensors data, license owners data, then land use data for this scenario. Okay, so let's say our next move. So merge land use and sensors and merge results with license, including suffixes. Okay, this I want to use suffixes for this. So merge land use and sensors on the word column. Let's merge land use and sensors on the word column. So it's going to be land sensors land use. Okay. Land use and sensors, these sensors on the word column, on this column rather. Oh. So let's land use sensors. We want to merge land use, this land use data. Dot, that should be dot merge. So I want to merge it to the sensors data, this data set here. To the sensors data. Land use dot merge to the sensors data. On which column? On the word column. There's a common column here. We have a word column here. We have a word column here. On the word column. So that's that. Close the bracket. Slash. So we need to make this result to the license table. And make the result with license including suffixes. So we want to make the result to the license table on word column. There's also word column here. So on the word column rather. That will be dot merge, comma, license data. This is my license owners data. On word also. But I want to add suffix 6 to it. So that's to differentiate the word column. No, we have three word column now. Word from here, word from here, and word from here. So we need to differentiate the common column that are between them. What services are we supposed to add? Using the services CN for left table and LIC for the right table. Okay, this for sensors. Okay, and LIC. I think we are good to go. Ooh, there's an error somewhere. Okay, I'm missing. No way, there's an error there. No way. Okay, let's see. Let me just copy this and make use of it. Yeah. Okay, so what is the error? We have an error somewhere. This is called land use. Just land use data. Then census, not census data. Then the last one is the license. It is running. Let's see if we actually make any mistake or made any mistake there. Why is it taking too much time to load? Wow. Uh, Come on. This last challenge shouldn't take long. We spent over an hour here. Okay, let's solve this last challenge. Let me just check where the error is coming from. Oh, it's supposed to be the opposite, the other way around. Not like this. You see? It's supposed to be like that, not the other way around. Voila. That was where my mistake is. It's supposed to be like that, not like. Let me just copy this line of code and refresh. Oh, we may have to reload the page for this to work. Now let's see, since we have this here, land underscore cn underscore lic dot add. I see that we made 32 tables together and it went out fine. Let's copy, let's drop this here and run the code. Voila. Mm, we shouldn't get any error. Let's submit. So we note that there. So group land cn by word pop the population in 2010 and vacant. Then count the number of accounts. Save the result as pop vac underscore lic. Oh, this is a lot to do. Let's see. We want to group what? We want to group this whole data set. How many rows of data here? Let me get rid of the idea first. We have over 19,000 rows of data and 19 columns. You see, 19 columns here. Let's do dot edge and see the results. Okay. Hmm. So we need to follow the instruction that says group the data frame by word. Want to go by word this column, and by population 2010. Population for 2010, this column, okay. This column and vacants. Which other column is that? Where's the vacant column? Let's see the vacant column. Where do we have the vacant column here? Okay, the index should be false. Okay, let's go by word. Go by word. Go by word. Okay. Then by pop 2010. That's another column in the data frame. Then finally by this vacant column here. Then count number of accounts. Account dot count. Okay, let me just copy this code here and see if you run into any error here. Land CNLAC. So this is our data frame here. Let's go. Good, no error. So I'll copy by these three. Let me just call on the results so you can see what we have here. Voila, I can see we are grouping by word up. We're counting the number of accounts in this combination of grouping by. So this is over 400. Let us do dot heads there. Voila, we have just few rows of data. Hopefully we are not sorting anything. Let's run the code. That's correct. And submit. Then finally sort by vacant account and top 10 in descending, ascending, and ascending order respectively. Oh, we need to sort by three variables. Sort by vacant, dot sort values by vacant, only sort by these three columns by vacant, account, word, and pop. Let's see. So sort population dot sort value. We're going to use the sort values method here. Then I'm going to list the columns I want to sort by in brackets, comma, by account, then by this population in 2010 column. Then we need to sort it descending, ascending, and ascending order. So this is going to go descending. That will be descending, right? So that will be false, false, comma. So this is going to go ascending. That will be true. Then ascending. The last column is going to go from lowest to highest. So let's see it in action. Okay. Ooh, we ran into an error. So if I'm to use, okay, I think since I'm doing ascending descending, I have to wrap them in bracket also. Okay, let's see. Voila, so that was my error there. So now let's call on this. You should see the results much more better the way we wanted. Okay, you can see now we have them sorted. This is going, this word is going from lowest, so I can see from lowest 7, from lowest to highest. But it has to be the combination of the three that will be sorted. Lowest, highest, highest. So this is the highest here. I see 5, but this is the lowest. So this is going to come first. That is the idea there. So dots head. Can see so ward 7 is probably the lowest population and has more vacant or land for use definitely based on the analysis. So I need to wrap these true false in bracket also. You can see the results here. So we have similar results here. Ward 7 population 515881, 51581. Ward 19, then account is 80. Ooh, hold up. Vacant. So I'm missing. Did we saw the account also? Sort by vacant account and pop. Okay, let's submit and see if I made a mistake. I got it. Why is my account now different here? This my account here is 80. The account here is 80, and mine is showing over 1,121. But row 47. Oh, definitely I've done a mistake. So probably I've added too many rows of data. But the next one is 1, 2, 3. 213. Ooh, my account is giving a different result though. I'm pretty sure the sorting is correct. But why is my account returning different results? I'll definitely troubleshoot that later. So let's troubleshoot that later. Great job putting your new skills into action. So you merge multiple tables with varying relationship and added suffixes to make your column names clearer. Using your skills, you're able to pull together information from different tables to see that seventh word would be a good place to build your goat farm. Interesting. Well, good job. So we completed the chapter one of this journey data with pandas. That took us at least 2 hours, 2 days to complete. So that's interesting. So I'm moving to merging table with different join types. So we're moving to left join, other joins, advanced merging. Let's take it little by little. So we'll see what we can learn in this chapter on day 33. So thanks for staying to the end of the live stream. So that'll be the end of the live stream for today. So if you found uh this learning journey interesting, do it to support the channel by giving the video a thumbs up. Just go to YouTube and hit that subscribe button. That will be very helpful. And give this video a thumbs up, like, let me know your thoughts in the comment section. And I'll see you in the next video on the channel. See you tomorrow, day 33, as we continue our Python learning journey.